Hello and welcome to Basic Arithmetic Without a Calculator. I'm Elizabeth Johnson and this is Lesson 5D, Addition and Subtraction of Fractions and Mixed Numerals. Let's have a look at these illustrations on your screen. On the left we've got a fraction that says 3/8. And the illustration is 3 pieces of pizza. Now, obviously, this pizza would have originally been cut into 8 pieces, and there's only 3 of them left here. That's where we got our 3/8. On the right, we have a pizza that would have been cut into 4s, and there's only one of those 4s left. So if I wanted to add or subtract these two fractions together, I'm going to have trouble doing it because they've been cut into different number of pieces. So what I want to do is I want to make sure they've both been cut into the same number of pieces first, and we're going to call those common denominators because when we do that, the bottom numbers of these fractions are going to be the same. So how do you do it? Let's see. Well, these are 3/8 and this is 1/4. What if I just chop this one into 8ths? Now it's 2/8. I can add 8ths and 8ths together. All right, let's have a look at what it would look like. I'm going to take this 3/8 and I'm going to add 1/4. So here we go. First step would be to rewrite both of these fractions with a common denominator, and that common denominator is 8. The 3/8, well, that's already got a denominator of 8, so the 3 will stay the same, 8 stays the same. But this 4, it became an 8 as soon as I chopped that piece in 2. So the 4 became doubled. And you'll probably notice that the 1 also became doubled when I chopped it in half. It became a 2. So I've got 8s all across. I can just keep the 8 the same. It's the numerators that we need to add. 3 plus 2 equals 5. Let's look at that illustration and see if that makes sense. You've got all 8s here. You've got 3/8 plus 2/8. That equals 5/8. Makes perfect sense. Let's see how it works when we do the subtraction. All right, it's going to be the same kind of problem. You can't subtract 4s from 8s. You have to make sure you've turned everything into the same number first, into the same denominator. So let's make some common denominators by chopping this 4th into 2/8. All right, and then we're going to rewrite our fractions so that they both have 8s at the bottom exactly as we did for addition. Each one will have an 8 as their common denominator. The first fraction didn't change. It's already got a denominator of 8, but the second fraction changed. 4 was multiplied times 2 to get 8. 1 must then be multiplied times 2 to get 2. Because remember, whatever you do to the bottom of a fraction, you have to do that to the top. That way it stays proportionate. Now we've got 8s as our denominator. We don't have to do any more work to that. We just leave it as 8, and we're going to subtract our numerators. 3 minus 2 equals 1. And let's look at our illustration again and see if that makes sense. This question is asking that if I had 3/8 and I took 2 of those 8s away, what would I end up with? Well, I'd end up with 1/8. So it all makes good sense. Let's have a look at a couple more examples. Here I've got 1/2 plus 3/8. And I want to add them together, but they've got different denominators. So I need to make sure that they both have the same denominator using equivalent fractions. The question I need to ask myself is what number can both of these divide evenly into with no remainders? And that answer is 8. 2 goes evenly into 8, and 8 goes evenly into 8. So I'm going to use 8 for a denominator. The second fraction didn't have to change, but the first one did. How did it change? Well, the 2 became an 8. Well, there's only so many ways you can turn a 2 into an 8. One of them is addition and subtraction. But we can rule that out because when you're making equivalent fractions, you will never add and you'll never subtract. You will only multiply and divide. So it has to be multiplication or division. That narrows it down to 2 options. And since the 8 is bigger than the 2, that tells us that we multiplied. 2 had to be multiplied times something to get 8. Now, the next question is, what did I multiply 2 by to get the 8? If ever I'm unsure, one way to find out is to use the reverse operation and divide. 8 divided by 2, that equals 4. I'm going to write that number 4 down here, because 2 had to be multiplied times 4 to get 8. And whatever I do to the 2, I have to do the same thing to the 1, the top number. So if I multiplied 2 times 4, I now have to multiply 1 times 4 to get my top number. 1 times 4 is 4. And it's true that 1/2 is equal to 4/8. And now that both of these numbers are the same, I can simply carry the denominator across, and I can add my numerators. 4 plus 3 is 7. So the answer to the first question is 7/8. On to the second example, 9/14 plus 2/7. I need to have a common denominator, and looking at the two of these, the first one I'm going to pick is 14, because both of these denominators can be evenly divided into 14 without any remainders. The first fraction did not have to change. It's already got a 14 at the bottom, so the 9 will stay the same. The second fraction had a 7 and it became 14. It became 14 because I multiplied it times 2. If I multiply the bottom times 2, I must multiply the top times 2. 2 times 2 is 4. Now my fractions are rewritten and I'm ready to do the maths. I've got 14s at the bottom and that stays the same, but the top is 9 plus 14. That's going to be 13. So the answer is 13/14. Now with this next example, we've got two denominators here that have absolutely nothing in common. What do you do when that happens? Well, one sure way to get a denominator will be to multiply these two together. It might not be your smallest denominator, but it will be a common denominator and it will work. So I'm going to multiply 4 times 3 and I'm going to end up with 12. 12 is my common denominator. So I'm going to rewrite both of these fractions with 12 at the bottom. Now, let's have another look. This 4 became a 12 because I multiplied it times 3. If I multiply the bottom times 3, I have to multiply the top times 3. 3 times 3 is 9. The second fraction, the 3 turned into 12 because I multiplied it by 4. 3 times 4 is 12. 1 times 4 is 4. Whatever I do to the bottom, I do to the top. And we're going to carry the 12 across, and we're going to add the numerators. 9 plus 4 is 13. But I'm not finished with this one yet, because it's an improper fraction. The top number ended up being larger than the bottom number. I'm going to have to fix it before I write my answer. How do you fix an improper fraction and turn it into a mixed numeral? You simply divide the bottom number up into the top number. I'll show you how it works. 12 gets divided into 13, so how many groups of 12 are in 13? Well, there's 1. 1 becomes your whole number, and there's 1 remaining. The remainder becomes your numerator. And as for the denominator, well, it just stays the same. So the answer is 1 and 1, 12. Now for the last example, you've got 2/3 plus 1/5. Again, these two denominators have nothing in common, so I'm going to multiply them together. 3 times 5, that gives us 15. 15 is going to be our denominator, so I'm going to rewrite these fractions both with a bottom number of 15. The fraction on the left had a 3 at the bottom. The 3 was multiplied times 5 to get that 15. So if I multiplied the bottom times 5, I must multiply the top times 5. 2 times 5 is 10. The fraction on the right has a 5 at the bottom and it became a 15 because I multiplied it times 3. If I multiplied the bottom number by 3, I have to multiply the top number by 3. 1 times 3 is 3. The 15 stays the same, and 10 gets added to 3 to make 13. That fraction is not an improper fraction, and it is simplified as simple as it's going to get. So that's the right answer. Now let's have a look at subtraction. Here we've got 1/2 minus 3/8. We need to give it common denominators. That denominator is going to be 8. So I'll rewrite it. The second fraction didn't change. The first fraction did. 2 was multiplied times 4 to get 8. So 1 must be multiplied times 4 to get 4. The 8 stays the same. The 4 gets subtracted 4 minus 3, so that equals 1. So our answer is actually 1/8. Now to the next one, 9/14 minus 2/7. Again, the denominator is going to be 14. So I rewrite both fractions with 14 at the bottom. The first fraction doesn't change. It's 9/14. The second fraction does. 7 was multiplied times 2 to get 14. So if I multiply the bottom times 2, I have to multiply the top times 2. 2 times 2 is 4. Again, we've got to carry our denominator across, and we'll subtract our numerators. 9 minus 4 equals 5. This answer is 5/14. Next question is this, 3/4 minus 1/3. The denominators will be multiplied together to find a common denominator, and that common denominator is 12. So we've got a fraction with 12 at the bottom minus another fraction with 12 at the bottom. This 4 became 12 when I multiplied it times 3. If the bottom gets multiplied times 3, the top gets multiplied times 3. 3 times 3 is 9. 3 became 12 when I multiplied it times 4. So if I multiply the bottom times 4, I'll multiply the top times 4. 1 times 4 is 4. Our denominator stays the same, and 9 minus 4 equals 5. So the answer to this question is 5/12. Now on to the last one, 2/3 minus 1/5. To get the denominator, we'll multiply the 2. 3 times 5 is 15. We'll rewrite them out, two fractions with 15 as their denominators. And now let's figure out what those numerators will be. On the left, 3 was multiplied times 5 to get 15. If the bottom was multiplied times 5, the top must be multiplied times 5. 2 times 5 is 10. And on the right, this 5 became 15 when I multiplied it times 3. If the bottom's multiplied times 3, the top will be multiplied times 3. 1 times 3 is 3. The denominator is carried across, and the numerators are subtracted. 10 minus 3 equals 7. So the answer is 7/15. And that's how you do addition and subtraction of fractions when they don't have a common denominator. You simply use equivalent fractions. But I'm just going to teach you one more thing. What if you've got mixed numerals or whole numerals mixed together with fractions? What do you do then? Well, the answer is you need to make sure that they're all the same, and usually you can pretty much bet that you can turn anything into a fraction and then you can work with it. So let's start by trying that. Let's try to turn this mixed numeral into a fraction and see if we can answer this question. Now the steps to turning a mixed numeral into an improper fraction are this. You take your denominator and you multiply it times your whole number. 2 times 1, well, that's 2. The second step is to add your numerator to that. 2 plus 1 equals 3. That final answer becomes your new numerator. And as for the denominator, well, it just stays the same. So 1 and 1/2 means the same thing as 3/2. So we're going to subtract from that 3/8. And looking at the denominators, unfortunately they're not the same, so we'll have to use some equivalent fractions to do this problem. Now, I'm going to use 8 as a common denominator, so I'll rewrite both of these fractions with a denominator of 8. Now the second one didn't have to change at all. So if the bottom number stays the same, the top number will stay the same. The second fraction had a 2, and the 2 is now an 8. So I had to multiply it times 4. 2 times 4 is 8. If I multiplied the bottom times 4, I have to multiply the top times 4. 3 times 4 is 12. Now we'll carry the 8 across, and we'll subtract the tops of the fraction. 12 minus 3 equals 9. And here we have an improper fraction. Remember how to change it back? You divide the bottom number up into the top number. 8 goes into 9 how many times? It goes 1 time, with 1 remaining. And our denominator, well, that's 8. So 1 and 1/2 minus 3/8 equals 1 and 1/8. Next one, we've got 4 plus 3/5. Well, that's quite simply 4 3/5. No worries. But what if I had to subtract it? What would I do then? Well, you would turn this whole number into a fraction. So you've got fractions and fractions. Now, how do you do that? Well, it's very, very simple. Anytime you take a whole number and put it on top of the number 1, it becomes an instant fraction. So 4 over 1 is the same thing as 4. All right, I'm going to subtract it from 3/5. And we don't have a common denominator, so we'll have to come up with one using equivalent fractions. The common denominator I want to use is going to be 5. 5 on the left, 5 on the right. The second fraction doesn't have to change, but the first one does. 1 got multiplied times 5 to get that 5. So if I multiplied the bottom times 5, I'll do the same for the top. 4 times 5 is 20. So the denominator is staying the same, but for the numerator I've got 20 minus 3, and I have an answer of 17. And that is an improper fraction. So I'm going to fix it and turn it into mixed numerals by dividing the bottom number up into the top number. How many 5s are in 17? Well, there are 3, with the remainder of 2. And what's my whole number, or my denominator? It's going to be 5. So I ended up with 3 and 2/5. And now we know how to turn a whole number into a fraction. Let's start with this next one. You've got whole numbers, or mixed numerals and mixed numerals. Now there's 2 ways to go about this. One of them is to take the whole numbers and subtract them, and then take the fractions and subtract them. But sometimes you'll find that that doesn't work, because maybe this fraction is smaller than that fraction. So one sure way to do it every time is to turn both of these mixed numerals into improper fractions. Well, that's okay. We needed the practice anyway. To turn this first mixed numeral into an improper fraction, multiply the 4 times 5 and you get 20. Now add that 20 to the 3 and you get 23. There's our new numerator. Denominator is 4. The next one will multiply again the denominator times the whole number. 4 times 2 gives you 8. And then we'll add the numerator, and that gives us 9. 9 is your new numerator, and 4 is your denominator? Well, the good news is we have a common denominator. So we don't have to make any equivalent fractions. We'll just carry the 4 across, and then we'll add the top numbers. Well, 23 plus 9, well, that would be 32. And again, we've got an improper fraction. What are we going to do with this improper fraction? We're going to try to turn it into mixed numerals by dividing the bottom number up into the top number. But wait, if I divide 4 into 32, it equals 8, and there's no remainders this time. So what do? Don't worry about it, just leave it as 8. That's the answer. Sometimes the answer doesn't have a fraction with it. Let's look at this final example. Now, here you've got a mixed numeral and a fraction, and we're subtracting. The way we're going to do it is to turn them both into fractions. The mixed numeral would become a fraction because I'm going to multiply the denominator times the whole number. 2 times 3 is 6. And then I'm going to add the numerator. That's a 7. 7 over 2 is my first fraction. I'm going to subtract from that 2/3. Now, you'll notice that I don't have a common denominator. So what I'm going to do is I'm going to multiply the two numbers together, and I end up with 6 as my common denominator. Now, this 2 was multiplied times 3. If the bottom number is multiplied times 3, the top number must be multiplied times 3. 7 times 3 is 21. The second fraction has a 3 at the bottom, and it became 6. It became 6 because I multiplied it times 2. If I multiply the bottom times 2, I will multiply the top times 2. 2 times 2 is 4. And now for the maths. We've got a 6 at the bottom. We've got 21 minus 4. And that gives us 17. Now, if you look carefully, you'll notice that this is an improper fraction. We've got to figure out how to turn it into a mixed numeral. And you should remember by now that you divide the bottom number up into the top number. How many 6's are in 17? Well, there's 2, with a remainder of 5. And what's your denominator? It's 6. So, there you have everything you need to know about adding and subtracting fractions, improper fractions, mixed numerals, all of it. So have a go at your sample questions and you should be an expert by the end of the day. I look forward to seeing you in the next video.